Good day. For those of you who do not know me, my name is Douglas Harder, and in this topic, we're going to look at the next chapter on the adjoint. So in this topic, we will define the adjoint of a linear map. We will demonstrate that the adjoint is a linear map too. We will describe what will be covered in the following chapter. Now, given a linear map that takes a vector space U to a vector space V, then we will define the adjoint of that linear map to be the linear map A star mapping V onto U, such that the inner product of A times U and V is equal to the inner product of U and the adjoint times V. Now, the existence of the adjoint is an upper year topic in pure mathematics. Hence, we will simply assume it exists. However, you may look up the Riesz representation theorem. Theorem: the adjoint is linear. Proof: well, if we take the adjoint of a linear combination of two vectors v1 and v2, and we take the inner product with a vector u, then that is equal to the inner product of A times u and that linear combination of vectors in V. However, from the properties of the inner product, we can rewrite this inner product as follows. And consequently, we can bring the adjoint back to the second term in the inner product. And now, once again, using the properties of the inner product, we see that the following is indeed true. Now, in the upcoming lectures in this chapter, we will look at the properties of the adjoint map, describe what the adjoint of a real matrix is, describe what the adjoint of a complex matrix is. We will reinterpret the inner product in terms of this adjoint. We will describe self-adjoint and skew-adjoint operators. We will consider some consequences of such operators. We'll describe normal operators, isometric operators, and look at linear regression. So following this topic, you now understand the definition of the adjoint of a linear map. You know that it is a linear map as well, and you are aware of the future topics we will be looking at in this chapter. Here are the references, acknowledgments, the colophon, and a disclaimer. Cheers!